All right, today we're going to be talking about displaying quantitative data with graphs. This is for chapter 1.2. So in this section, we're making a big switch from categorical variables to quantitative variables, and it's so important that you guys are able to tell the difference between them. So first, we're going to stop by reading dot plots. Brian and Jessica have decided to move and are considering 7 different cities. The dot plots below show the daily high temperatures in June, July, and August for these cities. Help them pick a city by answering the questions below. So number 1, what is the most important difference between cities A, B, and C? So if you look at these, they're all a little bit different in the middle. We're looking at their center. Number 2, what is the most important difference between cities C and D? Well, just looking at C and D, D looks a lot more spread out, doesn't it? So it's the spread variability. Number 3, what are 2 important differences between cities D and E? Well, if we look at cities D and E, we know that D is really spread out. E is kind of chunked in the middle with these crazy outliers on either side. So again, we're looking at spread and outliers. Lastly, what is the most important difference between cities C, F, and G? It's the shape. Notice how G tends to peak on the right, F is peaking on the left, and C is, I'd say it's kind of symmetric. So dot plots are so important. They're so much less abstract than histograms and box plots, and they're really going to make it easy to recognize features of a distribution of quantitative data. Take a second and read pages 25 through 27. So when describing the distribution of quantitative variable, what characteristics should be addressed? We have the shape. Is the distribution symmetrical or is it skewed to one side? Is a distribution unimodal where there's one peak or bimodal where there's 2 peaks? Then we have outliers. Are there any outliers present in the distribution? We have center. What is the mean and median of the distribution? And then we have spread, distribution, approximate range covered by the data. So an AP common error is when asked to describe a distribution, many students only comment on the shape. To get full credit, you guys are going to need to address the shape, center, spread, and any outliers. And we like to call this SOCS. Take a second and read pages 27 through 29. All right, I'd like you to briefly illustrate the following distribution shapes. We have symmetric, skewed right, and skewed left. So in the real world, distributions of data are almost never perfectly symmetric. You really want to describe the shape as roughly or as approximately symmetric. A fun way to think about skewed is by your feet. If a distribution is skewed to the left, it kind of looks like a left foot with the big toe on the right and the shorter toes on the left. Same with the distribution skewed to the right. Or you can kind of think of it skewed to the right if it's like stretched out to the right, kind of like you're grabbing it and pulling it. All right, next we have single-peaked, unimodal, double-peaked, bimodal, and uniform. Don't worry about the little ups and downs in a distribution. Little irregularities are to be expected. Basically, how you want to tell is if you were to drop a tablecloth over the graph, how many humps would you see? Take a second and read pages 29 through 30. So what are the 2 most important things to remember when you're asked to compare distributions? You want to compare them using explicit comparison words. Answers must be in context using the variable name, not just group names. So, how do the annual energy costs in dollars compare for refrigerators with top freezers and refrigerators with bottom freezers? The data below is from the May 2010 issue of Consumer Reports. So when you do this, you want to think SOCS. An AP common error is when asked to compare distributions, students are going to forget two things. 1, you want to address all 4 characteristics of SOCS. 2, you must explicitly compare each characteristic. Use phrases like about the same as and is much greater than when comparing the center and spread. So now let's go and take a look at this graph using SOCS. So shape. The distribution for bottom freezers looks skewed to the right and possibly binomial, with modes near 58 and 70 per year. The distribution for top freezers looks roughly symmetric, with its main peak centered near 55. In regards to outliers, there's a couple of bottom freezers with unusually high energy costs, over $140 per year. There are no outliers for the top freezers. Center. The typical energy cost for the bottom freezers is greater than the typical cost for the top freezers. Notice the midpoint of 69 versus the midpoint of 56. Lastly, we have spread. There's much more variability in the energy cost for the bottom freezers. So be really careful with your language. Notice how for shape I say the distribution for bottom freezers, as opposed to just bottom freezers look skewed. All right? I'm really describing them, saying, oh, it's skewed and possibly binomial. Okay? And notice how I'm talking about both graphs with great detail. Okay? Also notice how for center, I'm saying the typical energy cost for the bottom freezer is greater than the typical cost for top freezers. They're asking me to compare, so make sure you use words like greater than, okay? Or less than. Take a second and read pages 31 through 52. 31 through 32. All right, so what is the most important thing to remember when making a stem plot? You want to label variables and include your scale and key. So here I have a little example. Which gender is taller, male or females? A sample of 14-year-olds from the United Kingdom was randomly selected using the Census at School website. Here are the heights of the students in centimeters. So I have male and female. So first thing I'm doing when I'm making my stem and leaf plot is I make my stem. I make a leaf to the right and a leaf to the left, and I make sure that I include my labels. Also, notice how I have my key at the bottom. So an AP common error in this is when making a stem plot, a common error is to forget the key or labels. You will lose points for this on the AP exam. Don't lose points for such a silly error. Come on. All right. So the following table presents the average points scored per game for the 30 NBA teams in a recent season. Make a dot plot display per distribution of points per game. Then make a histogram. So what I did here to make the histogram and the dot plot is I used an applet, just kind of like the ones we were using in class today. I've linked the applet on the bottom of this, in the comment section of this video, in the description of this video. So you can use it for making histograms and your dot plots. So this histogram and dot plot were both created on the applet. Take a second and read pages 33 through 36. So how do you make a histogram? How is it different from a bar chart? First, you want to divide your data into classes of equal width. Then, find the count, frequency, or percent, relative frequency, of individuals in each class. Label and scale your axes and draw the histogram. So here are two examples of a bar chart versus a histogram. Notice how for the bar chart, there's graphs. There is graphs. There's gaps and categories versus the histogram, which has number ranges and no gaps. So an AP common error is when making graphs, students will often forget to label their axes. Make sure you guys are doing that. Label, 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 label. All right? When all else fails, label. All right, take a second and read pages 38 through 41. Why would we prefer relative frequency histogram to a frequency histogram? Well, relative frequency histograms are typically more useful than frequency histograms. They make it easier to compare two distributions, especially when the number of individuals is very different. So an example of that would be comparing distribution of GPA for our class and then the entire school. If we're doing our class, all right, then our number ranges would be a lot lower than the entire school when there's a whole bunch of students. If we are using relative frequency, then we're just looking at percentages, which would be a lot easier to do for different amounts.